Hello students, today we will see the application of total internal reflection. So the application on the basis of that the prism binoculars means these binoculars are used for to see the far away objects. Okay, so you will get the magnified image of that object by using this binoculars. In that binoculars, so lenses are there. So which one will be near to your eye? That is eyepiece and some distance. So we will one more eye lens are there. So that is the objective lens. One more lens that will be the objective lens, and near to your eye which one? That is the eyepiece. And two prisms are four prisms are kept in two cylindrical shape. And the distance between these two cylindrical shape will be very much less distance compared to our eye distance. That much less distance. So in order to overcome that one, prisms are kept inside. Okay. So how it will be, that we will see. So this is the eyepiece, and here, so this is the objective lens. Likewise, again one more cylinder will be there. Okay. Like this. So these two cylinders, the distance between them will be very much less than our eye distance, two eye distance, that much distance. So this is the objective lens, and this is the eyepiece. And inside this one, so two prisms are kept. One is like this way, and another one is like this way, and one is. So light rays will enter from the object, faraway object, whatever it is there, from the objective lens. Light rays enter, so it will make the reflection in side to side, and it will go, and up and down reflection will be there, and you will see the object. So like this we will do. So in this one binoculars, what happens? So refraction will take means multiple reflection. So up and down, two prisms are kept. So up and down, side to side. So all over orientation, the refraction will take place of the image. So that is a magnified image you will get. Okay. So this is a binoculars. So how they are using and all. This is a construction. So this is about your total and internal reflection applications and all. So periscope, binoculars, and optic fibers and all. So next we will see about the lenses. So already we discussed. So just we will recap something about the lenses. So lenses, when you consider, it is a spherical one, so which is having the one of the spherical surface and one will be the plane surface, or both may be the spherical surface. Okay, so that will be called as a lens. So in lens there are two types of lens: concave lens and convex lens. So this is a convex lens. So there is no polish here, both are transparent surfaces. Okay, in concave lens how it will be? So one may be the spherical, or both may be the lens. So this is a concave lens. Okay, so convex lens, concave lens. How will be the convex lens? Convex lens will be thinner at the edges and thicker at the middle. So when you are considering a concave lens, so this one will be thicker at the edges and thinner at the middle. So that is known as the convex lens, concave lens. Convex lens always thicker at the middle, thicker, and thinner at the edges. This one opposite, thicker at the edges and thinner at the middle. Middle it will be thinner at the middle. So you can make somewhat thin like this. Okay. So this is a concave lens. And when you are considering the Which one? Convex lens. Means convex lens is having two, right? So if you are considering this is your convex lens, two center of curvature, two radius of curvature, two focal length you will get. So whenever you are considering the concave lens, how concave lens will come? So concave lens will be, so if you are considering this is a two spheres, so this is your concave lens. Okay, so this is also having two center of curvature, radius of curvature and all. Okay, focal length. So this one is having a focal length positive and this is having a focal length negative. And the formula 1 by f is equal to, here length formula 1 by f is equal to 1 by b minus 1 by 2, where b is our main distance, b is the object distance, f is the focal length. Okay, and relation power and focal length same as like mirror. So what we discussed. So that is p is equal to 1 by f. Power is defined as p is equal to 1 by f. If you are using thin lenses of so many lenses, then power will be p is equal to 1 by f, 1